Let's take a look at dividing rational expression. And just a reminder for how division of fractions work in general. When you're dividing something by a fraction, you're going to flip the second fraction, find the reciprocal of it, and then you're going to multiply across. I'll show you what that looks like here, but before we do any multiplication, it's really useful to start by factoring everything. So here I have x squared plus 3x over x squared minus 16 divided by, I have x squared minus 9. On the bottom, I have x squared plus 2x minus 8. Okay, I'm going to start by factoring each of these pieces. I've got x squared plus 3x. These both have an x, so I'm going to factor out an x there. If I take out an x from x squared, I still have an x left. If I take out an x from the 3x, I still have a 3 left there. On the bottom, x squared minus 16. I'm looking for two numbers that would multiply to give me negative 16, but I don't have a center x term, so I want them to add to 0. So those numbers are x minus 4 and x plus 4. It's called a difference of squares. So negative 4 times 4 gives me negative 16, but negative 4 plus 4 gives me 0 as that center value. So I've factored this numerator, I factored this denominator, I'm going to keep going. X squared minus 9, that's a pretty similar situation here. I'm looking for two numbers that multiply to give me negative 9, but add to give me 0. So that's going to be a minus 3 plus 3 situation. I've got x squared plus 2x minus 8. So I'm looking for two numbers that multiply to give me negative 8, but add to give me 4. So that's going to be a 4 and a 2. Now I got to be careful with the signs. I want this to be a positive 2 here, so I want more of the 4 and a negative for the 2. 4 times negative 2 is negative 8. 4 take away 2 is positive 2. This is looking pretty good. So all I've done so far, and I've actually done a lot, so making that sound like it's a small task, but I would say this is the biggest task. I've factored each of these numerators and denominators. Now to divide, I'm going to flip the second fraction. So I'm going to change the top and the bottom. Everything else is staying the same. And then I'm going to multiply across. So this used to be on the bottom with this x plus 4, x minus 2. It's on the top now. This x minus 3, x plus 3, that's going to show up on the bottom now. And I'm going to multiply the tops and the bottoms. So I've got x plus 3, x plus 4, and x minus 2, all there on the top. And in the denominator, I have x minus 4. I have x plus 4. I have x minus 3. And finally, I've got x plus 3. I'm going to try to simplify this now by looking for any shared factors. X, just x on its own. I see a ton of x's here in the bottom, but nothing with just x. I have minus 4 plus 4 minus 3 plus 3, no solo x. X plus 3 as a set does show up in the bottom there. I can cancel those out. X plus 4 cancels out as well. But there's nothing to cancel out that x minus 2. So when I'm done, I end up with an x still left on the top, an x minus 2 still left in the top, In the bottom of the denominator, I have x minus 4. That didn't get crossed out. And x minus 3. This is the answer, but we often state the domain of anything that we crossed off along the way, so I wouldn't be able to plug in -3. That would give me 0 there. And I wouldn't be able to plug in -4. That would cause a 0 there. So when I'm dividing these rational expressions, I'm doing the same strategy that I actually do for multiplying. I'm going to factor everything out as much as possible. To divide a fraction, you're going to flip it. This is called finding the reciprocal, flipping it. I multiply straight across after I do that. I cancel any like terms. And then I state the restricted domain. So anything that I crossed out that would have caused a 0 earlier on, like -4 and -3, I state that in that final answer, just so anyone would know by looking at the problem. Hope that helps here. This is how to do dividing rational expressions.